Hi, this is Paul Battaglia, and we'll talk today about Section 1.5. In Sections 1.2, 3, and 4, students had exposure to limits in a variety of ways, but all of those ways handled one thing, and that was finite limits. Now it's time to talk about infinite limits. So the first thing we have to do is have students try and take away the idea that limits can exist and can approach numbers such as infinity or negative infinity, and that there might even be a connection between infinite limits and vertical asymptotes. So the essential question you want your students to be able to answer at the end of Section 1.5 is simply, what is an infinite limit? In the introductory example that we give in the text, it's a great opportunity to talk about mathematical practice for AP Calculus number 2. We want the students to be able to connect the concept we're talking about to its visual representation, sometimes with and sometimes without technology. And to that end, what might be a good idea is to look then further at example 1. And the big adjustment for students is they need to understand that we can now reach a conclusion of infinity. That doesn't necessarily have to coincide with the conclusion of does not exist. What do we mean by that? Well, so let's take, for instance, an example. The limit as x approaches 1 of 1 over x minus 1. Now, we can certainly use a table and a graph to help students initially grasp what we're talking about. But what we want them to see is as x gets closer and closer to 1, we can use a method they learned a couple sections ago, direct substitution. So we plug 1 in. Now we have 1 over 0. Now students are going to jump at the opportunity to say 1 over 0, can't have that, doesn't exist. And while that's true, we want them to start looking at the limit from both sides so they can get a better understanding of what the function is doing. So ask them, well, what's happening as x gets close to 1, let's say from the left-hand side? You may even have to put on the board something like 1 over 0.999 minus 1. So then we have to walk them through a little bit and say, well, what do we get? Well, now we get 1 over negative 0.001. Or 1 over negative 1/1000th. We may have to go further and say, let's get a little closer to 1. 1 over 0.9999 minus 1. 1 over negative 1/10,000th. What we want them to be able to do here is make the connection that 1 over a very small number, 1 over 1/1000th, 1 over 1/10,000th, is really getting larger in the grand scheme of things. So we want them to be able to say, well, wait a minute. As x gets close to 1 from the left-hand side, 0.999 minus 1, I'm getting negative values, but they're large in magnitude. What does that mean? Well, you're heading towards negative infinity. And if we went from the other side of 1 and we used 1.001, we'd be getting large in magnitude again, but towards positive infinity. Now students can conclude that the limit doesn't exist, but what they should also know is that we can conclude the limit as x approaches 1 from the left would be negative infinity, and from the right would be positive infinity. Why doesn't the limit exist as x approaches 1? Because those two one-sided limits do not approach the same value. The next thing you might want to think about is, how do I try and get my students to understand the connection between these infinite limits and vertical asymptotes? So what I would say is, ask a question. Does anybody here know what the connection is between an infinite limit and what's happening on the graph? And you might get crickets, or you might get a lot of enthusiasm, or you might have that one shy voice in the back saying, well, they occur, well, where? Where do they occur? They occur at non-removable discontinuities. This is what we want the students to come up with. So all that being said, what are some common mistakes that students might make? Well, now, since they've had to make this adjustment with this infinity as a conclusion, what we need for them to look out for, and you to look out for as a teacher, is, are my students correctly saying infinity when it's appropriate, or are they saying does not exist when it's appropriate? Likewise, when they state that there is a vertical asymptote somewhere, are they justifying why? Or are they just saying, there's just a vertical asymptote here? Because remember, the goal is to get away from the graphs and the tables and use those more as supporting evidence and use analytic methods to determine why things are happening. So in general, what we are looking for here from a common error standpoint and both on the AP exam is we want to see students be able to make that connection to infinity and vertical asymptotes as the limit as x approaches a number of a function, if it yields infinity from both sides, then the conclusion can be infinity. If it yields negative infinity from both sides, then the conclusion can be negative infinity. And what happens once again if the limits are not approaching the same value or the same theory in infinity? Then that's when we conclude does not exist. Look for this mistake if you're giving your students multiple choice type AP questions, because they're going to be very tempted to get the choice between infinity and does not exist, and that's where the confusion is going to come into play. I hope these tips have been helpful. I'm sure you have much success in section 1.5.